All right, I just want to provide a real quick clarification on the deflection calcs, not only for the example that we did in class, but for the homework assignment. So on the example that we did in class, what is still true is that the deflection at the center line of the beam for a simply supported beam with a point load is PL cubed over 48 EI. And that's for the live load applied. And we do still have a maximum deflection of L over 600. What I think would make the problem a lot clearer for you to do for your homework and whatnot is to compute the limit, the maximum deflection first. So the maximum deflection is L over 600, which is 35 feet times, 35 feet over 600, and then convert that to inches using the conversion factor of 12 inches per foot. I think I lost my parenthesis there. And so 35 times 12 is 0.7 inches. And so now what we can do is say 0.7 is equal to PL cubed over 48 EI. And now we can use our 1728. Because the 1728 is intended to yield an answer that's in inches. So by converting our deflection limit to inches, it makes everything a lot more straightforward. And so now what we do is we can just multiply both sides by 48 EI. So 0.7 times 48 EI is PL cubed times our conversion factor of 1728. And then all we have to do then is just divide both sides by 0.7 and 48E. So 0.7 48E. And if you notice, everything on the left is going to cancel, except for the I, which is what we're interested in. So therefore, our IX required is PL cubed over 0.7 inches times 48E. And then don't forget your conversion factor of 1728. So that equals P, which is 40 kips, L, which is 35 feet cubed, and then we can use the conversion factor like we've been using of 1728. And then on the bottom, 0.70 inches times 48 times 29,000 KSI. And so IX required, if you chug that out, so 40 times 35 to the third times 1728 divided by 0.7 times 48 times 29,000 equals 3041.38. Again, a lot more straightforward than having to derive a new conversion factor and a lot less clunky. So to make it a little easier for you, we can go ahead and look at the homework problem as well. So the homework problem has a maximum deflection limit. So the maximum deflection limit on the homework problem is, I believe it's L over 240. Let me make sure of that. Yes, L over 240. And we want to compare that against the center line deflection or the maximum deflection on the beam. Now, we don't use PL cubed over 48 EI because we now have a simply supported beam with a uniformly distributed load. So that's 5WL to the fourth over 384 EI. And so we use the same process. We take delta max, which is L over 240, which is 30 feet over 240. And then again, converting that to inches. So 30 times 12 divided by 240 is 1.5. And then we then say that 1.5 inches must equal 5 WL to the fourth over 384 EI. And then we do the same thing that we did, or the same approach that we did in the last one. So 1.5, multiply both sides by 384. And so divide both sides by everything but I. So therefore, this whole time, don't forget, you got to have your conversion factor. So yeah, it's a lot more straightforward to just convert your limit to inches, and then you can use the 1728 like you've done in the past. So 5 times 4.5 kips per foot times 30 feet to the fourth times 1728. I'll put that in green so that it matches what I've done before. And so let's chug that out. And that's IX required 1885. All right, so again, hopefully that's a lot more clear than last time. So again, it's the same approach. Before, just convert your maximum limit to inches and then plug and chug. Same thing here, convert your limit to inches, then plug and chug. And by doing that, you can use the 1728 like you've used before. That's all I have for this video. We'll see you next time.